Welcome to the debate. Today, we are stepping onto what is arguably the most treacherous ground in modern physics. We're challenging the sanctity of the vacuum itself. For over a century, the cornerstone of our understanding has been that the speed of light, c, is the absolute speed limit of the universe, a constant, written in stone, invariant in every frame of reference. But what if? What if we've been reading the equation backward? What if c isn't a limit on speed, but a measure of stiffness? Today, we're discussing supersymmetric geometric quantum mechanics, or SGQM, and the controversial Aetheron model.
That is certainly a provocative start, but we need to be incredibly careful here. You're talking about a framework that challenges not just a variable in a textbook, but the very way we perceive causality, history, even wave propagation. The central question we need to wrestle with today is, I think, pretty stark. Is the vacuum truly the empty stage governed by relativity that we think it is? Or is it, as SGQM proposes, a 12-dimensional rotating geometric lattice where light is nothing more than a modulus of elasticity?
Precisely. And my argument today is that the empty vacuum is a myth. I'm arguing that space is a dynamic, rotational manifold, the Aetheron. And within this framework, the speed of light is not a constant. It varies with curvature, effectively linking gravity and electromagnetism not as separate forces, but as geometric phases of the same structure.
And I'm here to represent the standard relativistic view, the view that has passed every experimental test, from the deflection of starlight to, the GPS satellites in our phones, which rely on general relativity to guide us to the grocery store. I'm deeply skeptical of the necessity, or frankly the wisdom, of discarding the constancy of light. I want to scrutinize the mathematical consequences of this Aetheron model, specifically what happens to the fine structure constant, alpha, if you start tinkering with light speed. Because if you break alpha, you don't just break a theory, you break the atom.
A fair warning, and one we will address directly. But let's begin with the foundation. The core of supersymmetric geometric quantum mechanics is a shift in perspective. We usually think of the universe as a container where things happen. SGQM posits that the container is the thing happening. The physical vacuum is a 12-dimensional rotational manifold. It's governed by a specific conservation law called the Aetheron theorem.
Which, looking at the math provided in the source material, bears a suspicious resemblance to the Pythagorean theorem.
Because fundamentally, it is the Pythagorean theorem, but applied to physical invariants rather than simple Euclidean distance. The theorem states that alpha squared equals mu squared plus e rod squared. Or to put it in terms relative to light speed, alpha times c squared equals m squared plus e squared. Now this isn't just simple shuffling. It tells us that mass, represented by mu, and energy, represented by E, are not separate entities. They are orthogonal projections, essentially the two legs of a right triangle of a single unified rotational state, which is alpha.
Okay, I will grant you the mathematical elegance of that. Using a Pythagorean relationship to unify bosons, which define forces and energy, and fermions, which define mass and matter, it is geometrically satisfying. You're essentially saying that matter is the vertical leg of the triangle, energy is the horizontal leg, and the hypotenuse is this conserved rotational magnitude.
Exactly. And think about what that implies for gravity. In this model, gravity isn't a mysterious force reaching out and pulling on planets. Gravity is geometric phase synchronization. The Aetheron invariant alpha must be conserved. So if you have a local increase in mass, a twist in the lattice, the surrounding rotational energy must adjust to compensate, to keep the hypotenuse constant. That adjustment doesn't propagate as a signal, it is a structural requirement of the manifold. It's a coherence condition.
Right, but this is where I have to push back, and hard. You're redefining the vacuum as a material lattice with properties like stiffness. This sounds uncomfortably like the luminiferous aether of the 19th century.
We spent decades getting rid of that idea after Michelson and Morley proved there was no ether wind. General relativity successfully explains time dilation and gravity as the curvature of space-time without needing a 12-dimensional substrate or a variable speed of light. Why introduce this complexity?
Because general relativity, for all its beauty, hits a wall. It breaks down at the singularity, and it cannot reconcile with quantum mechanics. And regarding Michelson and Morley, you're right, but they disproved a fluid aether, something that creates a wind as you move through it. The aetheron is not a fluid. It's a geometry. It's a solid-state lattice. And this brings us to the core of our disagreement, the nature of light. You see C as a velocity. SGQM sees C as a phase velocity modulus. Think of it as the stiffness of the lattice.
A modulus of elasticity, like in material science? So you're treating the vacuum like a block of steel?
In a sense, yes. If the aetheron is a lattice, it has a restoration rate. When you pluck a guitar string, the speed at which it snaps back depends on the tension and density of the string. That rate for the vacuum is C. Now here is where it gets truly interesting. The relationship derived in the material is alpha c squared equals m squared times the quantity c to the fourth minus 1. This equation creates a direct mechanical link between the fine structure constant alpha and the speed of light.
Hold on. Look at that relationship carefully. It implies an inverse correlation. If you change c, you must change alpha. You can't just tweak the speed of light in isolation.
Correct. And that is the feature, not the bug. In high curvature areas like near a black hole event horizon, the geometric density increases. The stiffness of the aetheron changes. As c, or specifically c to the fourth power, decreases, meaning light slows down due to the density of the medium, the fine structure constant alpha must increase to preserve the invariant.
But do you realize the implications of a bigger alpha? Alpha isn't just a number. It defines the strength of the electromagnetic interaction. It determines how tightly electrons are bound to atomic nuclei. If alpha changes significantly, atomic physics as we know it destabilizes. Chemistry would work differently near a black hole. Matter itself would behave differently.
And that is exactly what SGQM predicts. In those extreme gravity environments, electromagnetic interactions do become stronger. The stiffening of the electromagnetic bond is crucial. It is the very mechanism that prevents the aetheron from collapsing into a singularity. The geometry becomes so stiff, so electromagnetically dominant, that it halts the gravitational collapse.
So, you are trading the constancy of light for the stability of the singularity. You're saying that the only reason we get infinite density, a singularity, in general relativity is because we stubbornly insist that light speed and electromagnetic strength remain constant all the way down.
Exactly. In general relativity, the singularity is a breakdown of the math. Infinite density, zero volume. It's a here be dragon sign. SGQM says that by allowing alpha to rise as c falls, you hit a floor.
A geometric floor.
Yes, the system undergoes a topological phase transition. It doesn't crunch to zero. It hits a limit of rotational energy. It becomes a superdense, phase-locked state, but it remains physical. It remains finite.
I can see the utility in avoiding the singularity. That has always been the ugliest part of modern physics. However, I want to pivot to the observational consequences of this variable c. If light isn't a constant speed limit, how on earth do you explain time dilation? Special relativity is built on the idea that because c is invariant, time must dilate for moving observers to compensate. If c is just a stiffness variable, does time dilation disappear?
Not at all. It's reinterpreted. And arguably, the reinterpretation makes more intuitive sense. In SGQM, time is not a dimension you travel through like a tunnel. Time is an ordering parameter of internal rotation. Remember, in this model, every particle is a knot in this Aetheron lattice, spinning to maintain its existence.
So a particle is essentially a clock.
A particle is a 12-dimensional gyroscope, effectively. Now, consider the mechanism of phase locking. When a particle moves through the Aetheron or enters a gravity well where the curvature is high, its internal spin cycle its 720-degree spinor rotation must physically re-rotate to synchronize with the twisted background geometry.
Huh. Like a gyroscope resisting being tilted, you feel a resistance.
Precisely. That resynchronization takes energy. It creates a lag. The internal clock of the particle slows down because it is fighting to stay phase-locked with a denser or moving background. Dilation isn't magic geometry. It is the lag caused by the particle adjusting its rotational phase to match the environment.
So you are saying time dilation is a mechanical effect of this lattice interaction? It's friction?
It's a geometric friction in a sense. The faster you move, the harder the particle has to work to phase lock, and the slower its internal cycle completes relative to a stationary observer. It yields the exact same calculation for dilation as Einstein, but the why is different.
It is a compelling mechanical analogy, I'll admit. It grounds the concept of time in something physical rather than abstract. But this raises a massive question about Einstein himself. Einstein was not sloppy. He built general relativity on the equivalence principle and the curvature of spacetime. If this rotational aspect is so fundamental, this idea that the substrate spins, did Einstein just overlook it?
Einstein was a genius, but he was working with the tools of his time, primarily Riemann geometry, which deals with curved surfaces. He treated spacetime curvature as passive. Mass sits there, and space curves around it like a rubber sheet. He overlooked the intrinsic spin and torsion of the substrate itself.
You're referring to the rotational correction tensor, the F mu nu that appears in the SGQM field equations?
Yes. SGQM adds a rotation feedback term to the field equations. In standard GR, as we discussed, mass collapses to zero volume. But if you include the rotational energy of the substrate, the span of the 12-dimensional manifold, you get a repulsive effect.
Torsion. This sounds like Einstein-Cartan theory, where spin creates a repulsive force that combats gravity at high densities?
Effectively, yes. In SGQM, as matter collapses, the rotational energy E-rot must adjust to preserve the invariant alpha. The system hits that geometric floor we mentioned. It undergoes a topological phase transition rather than infinite collapse.
So you interpret this as a stiffening effect? The vacuum itself fights back against the crush of gravity?
It implies that black holes aren't holes. They're super-dense, phase-locked states of the Aetheron. And because they are states of matter and geometry, they preserve information. There is no information paradox, because nothing actually leaves the universe. It just enters a phase-locked state.
That is convenient for the theorists, but now I have to bring us back to reality. And by reality, I mean observational data. This brings me to the most radical and frankly hardest to swallow claim in this material, the non-propagation hypothesis.
I suspected we would end up here.
We have to. You're claiming that light and gravity don't travel as waves, but we have LIGO. We detected gravitational waves from colliding black holes. We can measure the delay, 7 milliseconds for example, between a detector in Hanford, Washington, and a detector in Livingston, Louisiana. That delay is calculated based on the speed of light. If waves don't travel, how do you explain LIGO?
This is the hardest conceptual leap, because we are so conditioned to think of packets of energy flying through space. Imagine a waterbed, or a vast tight net. If you push down on one corner of a waterbed, the pressure equalizes globally.
And practically instantaneously, assuming the medium is coherent.
Right. In a coherent solid, the stress field updates globally. But the observable ripple, the displacement that we can measure with a laser, travels at a limit defined by the medium's stiffness.
The speed of sound in the material.
Correct. In the Aetheron, that stiffness is defined by c. SGQM argues that LIGO is not detecting a wave that traveled a billion light years like a bullet. LIGO detects the localized oscillatory response of the Aetheron right here as it resynchronizes with the global change in geometry caused by the merger.
So you're saying the universe updates its geometry globally, but our local patch of space-time rings like a bell as it adjusts to that update?
Exactly. The ringing bell mechanism. The delay between detectors isn't the travel time of a wave packet. It's the phase lag of the Aetheron resynchronizing at different locations in the lattice due to their position relative to the source.
But that feels like a distinction without a difference. If it looks like a wave, moves at c, and carries energy, why not call it a wave? Why invent this complex global update with local ringing mechanism?
Because the mechanism matters for the anomalies. If it's just a wave, standard GR predicts a clean chirp and ring down. But if it's a lattice vibration, SGQM predicts post-merger echoes.
Echoes?
Residual lag effects. Because the Aetheron is a physical lattice with internal stiffness, it should vibrate after the event, like a drumhead settling down. There are claims of these echoes in the LIGO data, deviations that GR doesn't easily explain.
I am aware of those analyses. There have been papers suggesting echoes, though I must stress that they are heavily debated in the community. Many physicists believe those are just noise. But let's look at another piece of evidence mentioned in the source material, the precession of Mercury. Einstein became famous because GR calculated this perfectly 43 arc seconds per century.
Einstein calculated it by modifying the metric of spacetime. SGQM calculates it via magnetic leakage.
That sounds wildly different. Leakage sounds messy.
It's actually very precise. In SGQM, the mass coupling axis and the electromagnetic coupling axis are orthogonal but linked. Near a massive body like the Sun, there's a rotational feedback. The precession of Mercury isn't just due to passive curvature, it's due to the Aetheron's internal rotation interacting with the orbital rotation. It attributes the anomaly to a specific resonant coupling.
So you get the same number, the 43 arc seconds, but from a completely different physical derivation.
Yes, and that is the hallmark of a robust theory. If it can reproduce the successes of the old theory, like Mercury, while explaining the anomalies the old theory cannot, like the singularity or the vacuum energy catastrophe, it demands attention.
I will concede that point. The geometric floor offers a compelling solution to the singularity problem. Infinite density is a philosophical and mathematical nightmare, and if a variable c and a stiffening vacuum can prevent that, it is worth investigating. However, the risk remains immense. Abandoning constant c and wave propagation is a massive departure. If we're wrong about the relationship between c and alpha, we aren't just tweaking a theory, we are undermining the stability of the standard model.
It is a risk. Science requires risk, but look at the reward. A unified geometry where mass, energy, and light are all just different angles of the same rotation. The variation of alpha and c isn't a bug. It's the feature that keeps the universe stable. It's what stops the collapse. It turns the vacuum from a stage into an actor.
I suppose that is the beauty of this debate. We have the safety of the standard model, which works for almost everything, but breaks at the edge cases. And we have the Aetheron, which fixes the edge cases, but requires us to rethink the very ground we stand on.
And while the Aetheron model challenges the status quo, the concept of geometry as the soul of the universe forces us to look at those data anomalies, the echoes, the vacuum energy, with fresh eyes. Perhaps the vacuum isn't so empty after all.
It certainly makes you wonder what is really happening in the empty space between the stars.
Indeed. Thank you for joining the debate.